Hey guys, Absolute 5 here. So, today we're going to talk a little bit more about the derivatives of trigonometric functions, a little bit more because there's a few that I left out and I want to cover them all real quick right now and show you how you need to use your knowledge from pre-calculus of knowing what trigonometric identities are to use to help you solve a specific equation. So let's get right into all the derivatives of the trigonometric functions so we know the derivative of sine is cosine. We know that. The derivative of cosine x is negative sine x. The derivative of tan is secant square x. Let's write all the derivatives real quick. The derivative of cosecant x is negative cosecant cotangent. The derivative of secant is secant x tan x. And cotangent x is negative cosecant x. This is secant, cosecant. Making sure I know that. Oh, there's a square, right? There's a square. So these are a lot of tools to use to know how to apply them. You need to be able to know how to apply each one of them in a specific scenario that we're given. So let's get right into the example of what we're talking about. Yay! Dropping markers is fun. Okay, so let's say the example says f of x is equal to secant x all over 1 plus tan x, right? So this is the form of a quotient, so we have to take the derivative of it, we have to use the quotient rule. So f prime of x. So that's the denominator, 1 plus tan x, times the derivative of the numerator, secant, minus the numerator, secant x, times the derivative of the denominator, 1 plus tan x, all over the denominator getting squared. So this is something that you're not going to change. Okay. So 1 plus tan x times, so what's the derivative of secant? Secant is secant times tan x. Sorry, I had a brain fart there. Okay, so the derivative of secant is secant x times tan x. Secant times the derivative of this, derivative of 1 is 0 because it's a constant. Derivative of tan is secant square x all over 1 plus tan x getting squared. Okay, so now what am I doing here? Let's see. Let's distribute this with this, this with this, and so forth and so on. So 1 times this is going to be secant x tan x plus secant x tan square x. And this is just going to be negative secant to the third, x all over the denominator, which is 1 plus tan square x. It's okay if the camera doesn't catch that because the denominator doesn't really matter in this scenario. So then, go back up top. So let's factor out a secant in each term. Secant x. So it will be tan x plus tan square x minus secant square x all over the denominator. Okay? All over the denominator. Right. Okay, the next line now. Let's remember what this identity is. If you can remember what the identity of this is, it's pretty much, I have my notes somewhere. The identity is tan square x plus 1 equals secant square x. So we're going to use that here because we need to, I can see something's going to cancel out if I do that. Secant times x, tan x, plus tan square x minus, plug this in, plug that in here, I get tan square x plus 1 all, like another parentheses to close the bracket here, 1 plus tan, not tan squared, but tan x getting squared, there we go. And let's see what we have here. Lastly, we can immediately see this is going to happen. Secant x tan x plus tan square x minus tan square x minus 1, because I distribute the negative, parentheses, 1 plus tan x getting squared. And finally, we'll end it here. We know that these tans are going to cancel out in the end. They're just going to drop out. So your answer should be secant x times tan x minus 1 all over 1 plus tan x getting squared. So it takes practice to get good with all these trigonometric identities, so it's good to know all of them, especially if you're taking a calculus class. Ideally, again, you want to practice as much as possible. You want to get to know all the terms, including the stuff that you learn in pre-calculus. That's why one of my professors used to tell me that math is like a snowball effect, where you start easy in the beginning and eventually it accumulates over time and it keeps getting bigger and bigger and bigger because you use every single thing. Only in math, you use every single thing from the beginning all the way until now, and you constantly use it because you build up from what you started from the beginning, you know? It's kind of like that song, you know, started from the bottom, now we're here, you know, that kind of thing. Yes, that was corny. So anyway, that's the lesson for you guys. I hope you enjoyed it. I'm happy that, you know, I was able to show you guys. If you have any questions, be sure to leave them down below for me to answer. I'm always here for you guys. I also, you know, appreciate it if you give me some feedback, whether you want me to change something, or you want me to teach something specifically in math, because that's the best thing I could do is teach math. I can't really teach anything else. And that's basically it. So be sure to like, share, and subscribe to my channel. Also, be sure to hit that bell button next to the subscribe button if you like the content and you would like to receive more content. And that's basically it. So this has been Absolute 5. I'm Roger Palomino, and math is infinite because there are infinitely many possibilities.